Hello, welcome to today's video. Today we're going to be building a RetroWiFi modem. This is basically an old school type 56k looking modem that uses an ESP8266 to connect to your Wi-Fi and behaves like an old school 56k modem, so you can get your old retro computers such as the BBC Micro, Commodore 64, Amigas, Ataris, etc. onto the internet and looking at BBSs, etc. The main reason I wanted to have a go at this is it's not going to serve much of a purpose, but I just wanted to see if I could get the teletext on the BBC, because there is a teletext service, TFAX I believe it's called, so I wanted to have a go at that. The other thing about this one is put the LEDs in to make it look like an old school modem as well. So basically I have forked this from a guy called Ben MTL, who's also forked his project from someone else's, I forget who. The one change I've made, whereas he used a ReMOS Mini ESP board, I'm using a Node MCU board because I've got several lying around. So I've just basically swapped the ReMOS out for a Node MCU. So basically what you have is your RS232, RS423 I think it is on the beam, etc. signals coming into the connector from the computer serial port. Those go into a Max 3232 IC, which basically brings down the 232 levels of plus or minus 15 volts down to 5 volts before then feeding them on into the Node MCU to be processed and in the normal way. So the 232 is basically shifting the logic levels down to 5 volts so the other ICs can handle it. U174HC245 is basically used to level shift and it's used for LED control. One other IC is a 74HC32. It's a quad input NAND. I forget if it's a NAND gate or an OR gate. What that's for is we're using one input. Your other three inputs are tied down low to keep the outputs low. The one input we're using is on the transmit signal, the transmit line, and 3 volt line. I don't know if you know, when you're using an ESP86 and you're on a serial monitor and you reset, you get a lot of garbage characters come up, and then the OK comes, and you can start using. What this is doing is delaying that output to the screen to remove the garbage characters, so you just get the OK to save a bit of screen space. Power supply, you've got 5 volt input through the connector. That 5 volts is used to power the Node MCU and the HC245. It then gets brought down to 3.3 volts to power the HC32 and 3232 chip. One thing I am doing, the two HC chips, the 245 and 32, I'm using LS equivalents. Sometimes this will work, sometimes it won't. What the basic difference between HC and LS are the levels for triggering the highs and lows. This is the first and foremost difference. There are other variations, but too much to go into here. So I believe the LS chips will work anyway. The reason I'm using LS chips is because I had a lot of them about from when I repaired the Beeb. I bought a few in because I had to change quite a few chips on the Beeb to get it working, as it was bought broken. So next step will be building up the PCB. So that's the PCB design. Like I said, I've just changed the ReMOS for a Node MCU. So next step we'll start the PCB build. Okay, so next up we're on to the PCB build. I have created a PCB. Again, Gerbers are available on the Github. I'll put a link in the description. Again, I've got other bits as well, LEDs and resistors for the LEDs. Node MCU, that's a 3.3 volt regulator. Capacitors various. One of the capacitors, 1 microfarad, which I haven't got, so I'm going to put try and jerry rig 330 nanofarads to make 1 nanofarad. Barrel jack, DC barrel jack, connector, 10-way connector for the computer side. I've got 3 sockets for the 3 ICs. You've got the 232, max 3232, the HC245 and HC32. Again, obviously, like I said earlier, these are LS chips at the moment. And a one-off resistor, which is a 10k for the Node MCU. That's one of the inputs on the Node MCU. It's tied to 3 volts high. So we'll get on building that now. Let's get the soldering iron on. What I do first is I go from the lowest profile to the highest. Obviously, if you're going to be putting big tall connectors in and you've got some smaller components next to it, you get risk burning the plastics around. So we'll go low components to high components. Got a 3D printed PCB holder here. So first up, we'll put the resistors in. Resistors don't matter which way they go. They can go either way. There's being a bit OCD though and putting the stripes all the same way. It's in the right place. Sorry about shaking the camera, it's a bit of a Heath Robinson studio. Just light flex it on the resistors. So first up, I'm just going to get one leg and just get it tacked in place like that. See if we can get you closer in. Just get a small amount of solder on one leg. Tape off. Check everything's still down. Looks good. Oops. Try and get it in view of the camera. Like I said, not very Heath Robinson setup. One thing I've noticed, the microphone, I'm using the built-in microphone to the cameras and the computers, they're not the best. So the first purchase, if I carry on with this YouTube stuff, will be a decent microphone. So let's get the rest of these. Again, when you're soldering, give it time to flow and then pull away. And then once you've done that, go back to the first side and just make sure you've got enough solder on there and just bob in and out. Right, so that's them done. Cut the legs off. I do often, to show you, this is one of my third hand tool. I do keep the legs because sometimes I do stuff on perf boards. That's my multimeter switching itself off. It's always worth just doing another blob when you've cut the legs. Do some capacitors next. Do the 100 nanofarad. I believe the 100 nanofarads are 104s. There'll be printed 104s on the side there. Don't know how good that's coming out. Yeah, that's good. 104s, yep. So, okay, C7 is the different one. So let's put the 100 nanofarads in all the others. Okay. It's not brilliant, but never mind. C7 is a different one. I've got several projects on my Github. They've got PCBs for them. I've had to, they're on revision several due to the fact I always seem to make an error somewhere or another on my PCB design. One lead, I've had to cut leads and bodge wire them and so on and so forth. They generally work, there's just one trace seems to go wrong somewhere along the line. Okay, so let's get these taped in. So again, as with the resistors, we'll tack one leg in. I've forgot the flux again.
So I'm not sure if this flux is led through or not. Clearly it's got flux in this hour.
Yeah, we'll just do one leg on each cap. Sometimes if you think, oh, it's heating up, it's not that, it's the ground plane. You're trying to solder to a massive copper ground plane. If you have trouble with that, just back the temperature up a bit. I think we've got them all. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's another one somewhere. Ah, missed one. Again, same again, just make sure they're all still down. Okay. Finish soldering the legs off. And cut them off as per we did with the resistors. So we'll chop the legs off. I'm going to just go. I'm not going to put them in the collection of the others because I've got plenty of them. And then we'll just do a reflow. Yeah, looks good. Excuse me. Okay. These are 1000 nanofarads. 1 microfarad is 1000 nanofarads. I struggled to find one online. through eBay, etc. I have got some 330 nanofarads, so I'm thinking if I can manage to get 3 of these in series, I'm going to be close to a nanofarad. It's going to be very Heath Robinson. This is what I mean about the different footprints as well, because that will fit C6 perfectly, but it's not C6 that needs that footprint. What I'm going to do is get that first one soldered in, but leave it on a high-ish profile. Cut the legs off slightly long, and then I'm basically attempting to get 330 nanofarad capacitors in series into one set of holes because I haven't got a 1 microfarad. So I'm going to try and solder one on the bottom. Here's one.
So now it's 660 nanofarads. If I find one before I finish this build, I'll buy one microfarad, but just to get us going. This will suffice. Anyway.
What I've got to do is make sure I've got no shorts anywhere. So I've got, I don't know if you see this, I've got the first one in the holes. I've soldered one to the legs on that side and one to the legs on that side, so that's 990 nanofarads, which is close to microfarad, I believe. Looking at the charts, we'll see anyway. So that's that. That's mostly, apart from the LEDs, I'm going to do those last because they're out the way over here. Plus these being used, I've got to clean them up a bit. So next I am going to do the volts regulator next. I apologise if we do have chunks of video missing. My camera keeps shutting off and I don't know. What it does, it stops recording and then shuts off a little bit later, but it doesn't. Obviously I hear it shut off, but I don't hear it stop recording. Right, there's your 3.3 volt regulator.
That's the ground plane.
So you can get all 3 off at once. So that's that it. And while we're in that area, we'll do the barrel jack. This will take a bit of heat and solder. Splash some flux on that because I forgot to do it on the other. This solder's probably got flux in it anyway, but right, let's get the first one. Which one's the ground plane? And avoid that one. That one's the ground plane, so I will do that last. So we've got that tacked Oh, no we haven't. I will get the soldering iron back on there and it melted. And make sure everything's flat to the board. There you go, got it. Let it cure. Check the other side, that's fine. So all we have left now, sockets and connectors and ESP32. So sockets and connectors. This connector's got a cutout. That's a key, so you can't get the plug in the wrong way round. The silk screen. Silk screen will have that cutout there, so that's how you put that in. So cutout on the right hand side. Same with the dip sockets. These are called dip sockets because you've got a small half circular cutout at the top there, and you've got a half circle on the silk screen, so you make sure you got that right way around, because the ICs themselves, put my wrist strap on before I handle the ICs. Got a strap. Don't know if, well, you'll be able to see this. Let's get focused in. There you go. On the top there, you've got a half cutout. That indicates pin 1, which is the top left. So that's how you line all your sockets and ICs up. What I'll do, I'll get the solder up in the air like that. Hold it from underneath, like that. In the tip. Get a blob of solder and get it tacked in. No, not tacked in yet, we need more solder. It's a bit rough, but that's all. But then we're going to fucking, I've got it on an earth pin there, so I'm going to try one of the other pins first. There you go. So I need to make sure it's flat. Yeah, I think I picked 2 ground planes there to tack it in, which is not a good idea. So basically tack opposite corners, and then you can reflow each corner holding the socket in to get it flat to the board. Yeah, that looks better. It's got a burny looking appearance. That's because there's a piece of ground plane missing there. Well, not missing, it wasn't, because it's encircled, it's not put a ground plane in between. All this lighter green is ground plane. So again, half circle to half circle, so you've got pin 1. Let's try not to tack it down on a ground plane this time. Let's get a bit of solder on the tip. I think that's in. Yeah, that's in. Opposite corner. That's in. Make sure we're flat. Looking good. Get a bit closer in on some soldering action. Get some flux on there. Get this board cleaned off later on. I've got an ultrasonic cleaner, small one, so I'll have to do it in 2 hours. But so I've done that corner and that corner, so I'll start up here, do it down here and then go up. Okay, so what I'm going to do now, I've got 2 more sockets to do. I'm not going to bore you with that. I'll be back when we come to put this ESP 32 on. Okay, so I've now got everything on the board. LEDs, resistors, sockets, capacitors, power in, regulator. All I've got left now is to put the ESP on. So, a little tip, when you're buying any kind of board like this, is to buy them unsoldered. I bought this pre-soldered. The problem I've got is they're not matching up, because I don't know if you can see it on the camera, the legs are splayed inwards. So the tip is to buy them unsoldered, solder the legs on yourself, because you can solder them in situ then. So what I've had to do to alleviate that problem is get some of these pin headers, female pin headers, to take up the slack. There you go, so it's in now. So same as everything else, I've got my wrist strap on because I'm handling the ESP. Get 2 corners in. So I'll put some flux on first. A bit of solder on the tip. Do 2 opposite corner pins. Next one. Next to that. Make sure everything's flat. You can see through. I'll show you that in a minute when I get the soldering on. You can see how the legs are splayed outwards. In fact, the board's moving about now because I've got a high profile part on, so I'm going to get it. Let's just come in focus. That's that. So that's everything soldered on now. Get the chips in the sockets. Sometimes when you're trying to put these dips in, they come splayed outwards. If you can see it, splayed outwards. What we do is get it on a flat surface and just bend it in. Make sure you haven't bent any of the pins. And always go in, get the one side in first and push over. That's in. So you've got half circle, half circle. So that's board complete. So next up we'll need to build some cables, sort the case out and test it. So next up we're just going to give the back of the board a clean using some IPA.
Get the excess flux off the board.
I will put it in the ultrasonic cleaner later on.
Just calculate the fluid cleaner in the I haven't decided. Well, I've got some IPA in a bottle. I put it in ultrasonic, but I was going to do it outside because obviously being flammable and the ultrasonic cleaner does heat the fluid up. So I've got the excess off there. What I'm going to do next, it's still wet, just get a brush out of it. That gets off any bits of cotton bud. Two different kinds of it.
This is I've never tried this before, but I've seen someone do this. So get up the excess. This is a sterile, right? This is, but I've seen a guy using rags and all sorts of stuff. We just seem to mop up the excess very well.
Obviously, chemical watch, but I've got alcohol in this as well anyway. That's dry off.
Still a bit sticky. Still a bit of residue on there, but I'll clean up, get that off. Okay, so I've took all the chips back out. Before I power up, I want to do a sanity check on the voltages on the board to all the chips and the MCU. We have a 5 volt input, so we'll get DC volts. First of all, we'll check the input on the regulator, 5.13, and the output 3.3, so that's okay. So volts in to the node MCU is 5 volts. Yeah, 5.1. D5 connection 3.3 volts. Yeah. So U1, which is HC245, is 5 volts on pin 1. Oh, sorry, pin 20. So that's your main VIN for your 245. The HC32, 3.3 volts on pin 14. So it's a 7 pin, so it's 14 there, pin 14, 3.3. And finally, the Max 232 is a 3.3 volt on pin 16. 16 is 3.3. Yeah, so it's basically all the pins at the end on the right hand side. 3.3, 5.1, sorry, for U1. I'm not sure why we've got 3.3 volt on the HC32. I'm pretty sure that's a 5 volt chip, but that's what it says, so we'll go with that. It's what it says, and it's what it's reading, so I'm happy with that. Pin 1, pin 1, pin 1, pin 1, pin 1. Good. So let's get back 5 volts back on the supply. Get there in a minute. 5.1. See if you get any magic smoke. Oh, that made me jump. So we've got green LEDs instead of red ones. Oh well, never mind. Okay. Just make sure you're not getting super hot on anything. Yeah, so it looks like we're good there.